welcome everybody to building an interpreter and compiler. A few things about what we want to do and why I think that's a good idea. So our goal is to, or my goal is to teach you how to build a simple interpreter and then work up to building a compiler in very, very small incremental steps. And one of my philosophies with that, or one of the goals of the goal, is to make compilers and interpreters less of a black box. Because for many people, compilers and interpreters are kind of like this magical thing that just does something, but they don't know how. But they're not actually magical. You can understand what they're doing, and that's what I'm trying to show. And so one of the things that come from that is that we're not going to use any pre-made standard tools for building compilers. Especially, we're not going to use like an existing compiler backend to do the code generation for us. We're not going to use LLVM. We're not going to use a parser generator. We're not going to use a scanner generator, because those again are black boxes that, you know, you're just shifting the black box to a different box kind of, but you still have a black box. But we want to try to get rid of the black box and understand everything. Does that make sense to everybody?
Yes.
The way our interpreter and later our compiler is going to be structured is that at the very start, what pretty much all compilers do is lexical analysis. So that means breaking up the source code into individual tokens. And that's the first assignment that we're going to do. And based on top of that, there's going to be a parser that actually analyzes the syntax. So we will try to make the scanner in such a way that the parser can build on top of it. I should talk a little bit about the repo of Simplang. So what we have here is the README is a little bit of maybe a bit too technical description of the language, but there's a few examples, so I hope it makes sense. And also there's the video that I made with Bete that I should actually link on the wiki, which I'm going to do afterwards. But I hope most of you have seen it. If not, I'm gonna put the link in the wiki. So in that video, we're programming a little bit in Simplang, which should make it clear how Simplang itself works. And Simplang is a very simple functional programming language. There's no type system. Everything is a number. You can't actually do that much with it, although it contains a lot of the interesting problems that you have to solve when you write a compiler. So that's the README. Then there is the assignments document, which is the things that I'm going to ask you to do. And today's assignment is 1.1, which is a sub-assignment of assignment 1, which is to write an interpreter. So as you can see, once we have the lexical analyzer, we will then start writing a parser for a very, very simple subset of the language, and then we'll write an interpreter for this very, very simple subset. And then we will slowly expand the subset of the language to eventually end up with the whole language at the end, and we'll have a complete interpreter. And then we go on and we do the same thing for a compiler, except that we start first with a compiler for a virtual machine, a very simple virtual machine, which also means that we'll have to write an interpreter for the virtual machine. And the reason for this virtual machine thing is, first of all, it makes writing an interpreter easier because you don't have to deal right away with the idiosyncrasies of an actual CPU instruction set, which some of them are a little bit weird. Almost all of them have some weird things, but AMD 64 in particular has quite a few weird things. But the other is that actually a lot of programming language implementations use virtual machines. So I think it's also interesting and important to understand how these work. So for example, Python, CPython is an interpreter that's actually a compiler from Python to a simple virtual machine, which is then interpreted in C. Other languages like C# and Java also work kind of the same way, except that the virtual machines in their cases are public, in the sense that they're not implementation details, so you can actually target the virtual machines directly, and they're supported and documented and everything. And but usually the runtime environments contain just-in-time compilers, so they're not interpreted. The code for the virtual machine is then compiled on the fly to native machine code, sometimes ahead of time. All right, so that's the assignment. But I'm going to talk about the assignment later, but I'm going to show you more in the repo. There is also later for the virtual, once we get to the virtual machine, there's the virtual machine specification and description, and then forget the hints. I should delete that file. That was bullshit from quite a while ago. Then there's lots of, actually no. Then there's lots of examples in the examples folder. So like a very trivial Fibonacci. Once you have the scanner, all of these should actually scan, except for the SBC. That's a thing for later. That's actually virtual machine code that you can test your virtual machine on. But all the .sl files should successfully scan. Then there is also, if you want to play with that, there is one very simple implementation that I did in the implementations folder, which, however, requires Mono to work, unless you're on Windows, in which case it doesn't require anything. But let's see. If you have Mono, you can run, and you can. Mono is easy to install. I just installed it here with Homebrew, and on Linux it's even easy. So you can run the interpreter, and you can run it on one of the examples. Let's say Fibonacci.sl, and we're going to run it with argument 10, and it's going to give us the answer 55. So this interpreter should work correctly on all correct Simplank programs. It might not. It might still give you answers for incorrect programs. So it's not written to detect errors necessarily. And also, if you don't give it required arguments, it will just throw an exception because I'm lazy. Maybe I should fix that. And then there's the tests, and I'm going to talk about those later once I talk about the first assignment. So first assignment. Oh, and by the way, if at any point anything is not clear, please just interrupt me and ask. Otherwise, I'll just keep on talking. So as I said, the lexical analyzer is a very simple program or part of a program that breaks up the input into individual tokens. And the tokens that that are relevant in Simplang are keywords, which are exactly these. So these are kind of like fixed in the language. You can't use those for variable names, for example. Then there's identifiers, and identifiers have to start with a letter or an underscore, and they contain letters, digits, and underscores. Then there's the operators. There are these. Some of them have 2 characters. Most of them have just 1. And then there's integers, and integers are just sequences of digits. So here's an example. Your scanner program. So ideally, you would write a scan function that returns the next token, and then you'll have a driver that produces this output. So I would not write the scanner to produce the output directly, because as I said, in the next assignment, we're going to write a parser. So the parser will expect or need a function that produces tokens. But you know, it's not going to be that hard to rewrite. So at the end of the day, do whatever you think is best. So here we have a keyword, let, that's output in 1 line. Then we have an identifier. Then we have the operator equals. Then we have an integer. Again, an identifier. White space is ignored, except for as a separator between tokens. So this is not the identifier let A or let A, right? It's let and then A, because there's a white space in between here. So white space is relevant in that sense, but otherwise we ignore it. But note, however, on the other hand, that white space is not required to separate tokens. This is the identifier A, and then there is the operator plus and the operator minus and the integer 1. Any questions so far?
Nope.
Okay. So now I can show you. I've written a little test driver that you can actually use to test the thing. It's in the tests directory, test.py. Call it. By the way, can you see this? Is this too small?
Just a little, maybe. Can you? I like that.
Okay. So in the test directory, there's so far only these two subdirectories. The one is for the full interpreter, and the other is just for the scanner. So scanner contains the tests for the scanner. So what you tell the test script is come again. I'm sorry.
No, it's okay. It's okay.
So you tell the test script the test directory in this case, and just the name of the directory, not the actual path to it. And then your executable and however many flags are required to give to your executable. And then the test script will also give a file name to your executable. So in my case, I have an implementation here that is not in the repo. And what I have to tell it is --scan, and then I can give it, for example, the fib.sl. And if I call it like that, it will output the tokens in that Simplang file. So if I want to run the tests on my scanner, I have to remove that file, and then I have to call tests. Test.py with that, and of course I didn't give it the directory. Scanner And ta-da, it works. It will not work if I don't give it that. Then it'll actually just crash. Okay, any questions regarding the tests? All right. Yes, also the wiki. So we're gonna have our next call on Friday. I'll actually put up links to the YouTube stuff here, and I'll maybe write a paragraph about what we talked about. So I suggest you do the assignment until Friday, because then we can talk about potential problems that you had, and also I will write a quick implementation so you can see how I would do it. And that's going to obviously make more sense if you've actually done it yourself. If you have any questions at any point, either about the assignment or about anything else, just feel free to ask on Slack, and I'm happy to help you. I would also ask you to, so you probably just want to fork the Simplang repo on GitHub and work in there. And unless you have, I don't know, an objection to that. But it would be nice if you could send me your repo links and let me look at your code when you're done, or even if you have questions in between, because I'd like to, give you feedback on that. Right. What else did I have on my agenda? Yeah, that's pretty much it. So, any questions, concerns?
No, not really.
All right. Well, in that case, go forth and write a scanner. I'll talk to you soon. Bye.
Bye.